Lesson 9.7, Part 2. Essential question. Can I use the law of cosines to find angles and sides of an ordinary triangle? Let's look at the proof. We're going to draw an ordinary triangle and draw its altitude. And when we do that, we create a right triangle. Actually, two right triangles. So this is definition of right angle. Once you have a right angle, then you have right triangles. We're going to use the Pythagorean theorem on that polka dot triangle right here. So the hypotenuse squared is equal to the leg squared and the other leg squared. And we're going to take this b minus x and we're going to expand it. Over here I've expanded it, and all you have to do is use FOIL. First, inner, outer, last. So here are the first terms, which is here, outer and inner, and then last term. So this is going to be equal to b squared minus 2bx plus x squared. And on this triangle, I'm going to use the Pythagorean theorem right over here. And so what we're going to do is we're going to take this portion and we're going to replace this with that. And so I'm going to get this quantity. I'm going to say a squared equals, and then I'm going to write this, b squared minus 2bx plus x squared plus h squared. Now this part right here, x squared plus h squared, I can cross out and replace it with c squared. And that's the substitution property. Now what I'd like to do is take care of this x right here. So I'm going to go back to angle A, and angle A is the adjacent over the hypotenuse. So that's the definition of the cosine ratio. And then I'm going to do some cross multiply, and I'm going to rewrite line 3. So on line 6, so this is a squared right here, b squared right here. I have this c squared I've written here, minus 2b, and then I'm going to replace this x with this part right here, and that's called substitution. And this is the law of cosines. Let's look at it more closely. So this says that a side squared is equal to the sum of the other two side squares minus 2 times the product of those two sides times the cosine of angle A. And angle A is always the angle opposite the side you started with. And if you go through this other patterns, you'll see that's just the same thing. Now, what happens, let's put this in your calculator. What's the cosine of 90 degrees? Now, this is really for future courses, but I just wanted you to see that the cosine of 90 is equal to 0. So if this triangle happens to be a right triangle where angle A is 90 degrees, this part becomes 0. And when this is 0, this whole thing right here is 0, and then you're only left with this part of the formula. Do you recognize that? That's the Pythagorean theorem. And this happens each time this angle ends up being 90 degrees. Now, we are not going to use the law of cosines for things that are right triangles. We already have things to use. So we use law of cosines for triangles that are not right triangles. And again, one side squared is equal to the sum of the other two squares minus 2 times the product of the two sides times the cosine of the angle, again, that you started with. Let's take a look at a problem. And notice that I have angle B and I'm looking for side B. So I'm going to write side B squared equals, now the other two sides are a squared plus c squared minus 2 times, I'm going to use these two letters, a times c times the cosine, and if it's angle B, because angle B is opposite this side here. So I'm going to put all my numbers in. B squared is equal to A is 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of B. And B will be equal to the square root of this quantity right here. which I'm about to put in my calculator. Again, I let my calculator do all the work. I don't do all the work. Okay, so I'm going to go ahead and put that in. Square root 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of, now B was 34 degrees. I should have put a 34 here. So this is going to be 34. And I'm going to get B to be approximately 7.9. Now it says to solve the triangle, and solving the triangle means I've got to find all the parts. I found this side, but now I need to find the angles. So to do that, I'm going to go back to my law of sines. So sine of 34 over, now I have the 7.9 is equal to the sine of A all over 11, which is equal to the sine of C over 14. And I'm just going to use this portion right here, and I'm going to cross multiply. So this is 11 sine of 34 is equal to 7.9 sine of A. I'm going to divide, and I'm going to have 11 sine of 34 over 7.9, and the measure of angle A will be equal to the sine inverse of this quantity. The calculator can take it, and I'm going to go ahead and put that in. Sine inverse, and 11 sine of 34 divided by 7.9, and I'm going to get this to be approximately 51.1 degrees. So angle A is approximately 51.1 degrees. Then I subtract from 180 those two angles. And for angle C, I'm going to get 94.9 degrees. And this is called solving the triangle. Okay, let's go ahead and I'll help you out with 11, and you will be doing 12. All right, so I have angle B, and so let me go ahead and set up the law of cosines. Remember the law of cosines, you must use SAS when you have two sides and an included angle, or when you have three sides. So let me go ahead and do that. I'm going to write B squared equals the two sides, 45 squared plus 43 squared minus 2 times the 45 times the 43 times the cosine of 88 degrees. And you actually can just find all of this if you want, and then once you get it, you take the square root. It really doesn't matter how you get it. So just put it in the calculator. Okay, and I'm getting B to be 61.1. Okay, at this point I need to go ahead and use the law of sines to help me do the rest of the problem. Sine of 88 over 61.1 is equal to the sine of C all over 43. And so I know that the measure of angle C will be equal to, remember I'm going to cross multiply, sine inverse of 43 sine of 88 divided by 61.1. So let me go ahead and put that in the calculator. Sine inverse of 43 sine of 88 divided by 61.1. And I get my angle to be approximately 44.7 degrees. So angle C is 44.7 degrees. Subtract from 180. And the other angle, angle C, is 47.3 degrees. Okay, stop the screencast and see what you can do with number 12. And here is the answer. Okay, solving the triangle. In this case, this is side, side, side. So again, I'm going to use the law of cosines. Let me go ahead and I'm going to work with angle C. So this is going to be 20 squared equals 12 squared plus 27 squared minus 2 times 12 times 27 times the cosine of C. Remember that the angle C and the side C must be at opposite ends. So I'm not going to do any squaring. I'm going to do that at the very end. I'm going to subtract all those things that are being added, and then I have this. Now to get rid of this, I'm going to have to divide both sides, and I'm going to have 20 squared minus 12 squared minus 27 squared, all divided by negative 2 times 12 times 27. So the measure of angle C will be equal to the cosine inverse of 20 squared minus 12 squared minus 27 squared all over negative 2 times 12 times 27. Now when you put it in your calculator, you must make sure the calculator knows this is your numerator and this is your denominator. So you will have to put an extra set of parentheses when you put it in the calculator. So cosine inverse, and I'm putting another set of parentheses, 20 squared minus 12 squared minus 27 squared, parentheses, divide, parentheses, negative 2 times 12 times 27, and then finish your parentheses. And I get for the measure of angle C approximately 43.1 degrees. So angle C is approximately 43.1 degrees. Now to figure out the other angles, you have to go to law of sines. So sine of 43.1 degree all over 20 is equal to sine of A all over 12. You're going to cross multiply and then divide by this number. So sine inverse of, you're going to multiply these two, 12, sine of 43.1 divided by 20 will be equal to the measure of angle A. All right, let's go ahead and put that in. Sine inverse, and then I'm going to put 12 sine of 43.1 divided by 20, and I'm getting approximately 24.2 degrees. So 24.2 degrees. Subtract from 180 to get that last angle. And I get this angle to be 112.7. Okay, so these are both SSS's, SSS, and SSS. Go ahead and try number 14, and I will have the answer. And here's the answer. And this is the end of the screencast.